So now we're going with cast again, and we're looking at reference angles and continuing to move through this whole main idea with the angles theories. So we're going to be able to determine trig ratios, we're going to be able to do reference angles, and we're going to be able to do all of that. So if you remember cast rule here, so given our angles and our trig ratios, that's going to be important for this lesson. So exact values of trig ratios given a point on the terminal arm. So remember, if you have a point, you go ahead and you sketch it. So -3, +2 is going to look something like that. So -3, +2. And then we always calculate the missing side. So we're going to calculate r in this case. So r is -3 squared plus 2 squared, which gives me 9 plus 4. And 9 plus 4 is 13. And then remember, we have to square root 13. So our r in this case is the root of 13. So now it says use trig ratios to write the three, or using those values, write the 3 trig ratios for SOHCAHTOA. So for sine, it's opposite over hypotenuse. So our opposite is 2, and our hypotenuse is root 13. And it's positive because it's in the second quadrant. For cosine, it is -3 adjacent over hypotenuse. So x over r, -3 over root 13. So that gives us our cosine. And then lastly, we have our tangent, which is opposite over adjacent, which is 2 over -3. So there's our trig ratios for that. And now it says the point -4, -2 lies on the terminal arm, so we're going to go ahead and put that on the graph. So there's our point -4, -2. And if I make my triangle with that, I have my triangle. So there's -4, -2, and I'm going to have to find my hypotenuse. So I'd have -4 squared plus -2 squared. That is 16 plus 4, which is equal to 20. And then the root of 20 does simplify because we can prime factor 20 here. So 20 divided by 2 is 10, divided by 2 is 5, divided by 5 is 1. So the root of 20 equals to 2 root 5. So then sine is opposite over hypotenuse. So that would give us a -2 over 2 root 5. And that can simplify to -1 over root 5. Now, if you remember, and it is going to come up further in this lesson, we don't really like writing radicals on the bottom of our fractions. So what you could see this as, if you remember back to your radicals unit, this could also be written as -5 root 5 over 5, because we could multiply top and bottom by the square root of 5 to get rid of it. And that's just rationalizing the denominator. So value of a trig ratio given a different trig ratio. So if we're given the ratio, we need to draw the triangle and put down the values we know. So for example, here it says we know sine. So sine gives us our radius and our opposite side. So it says I have sine, that's -4/5. So sine could be negative in this quadrant, or it could be negative in this quadrant, given cast rule. So -4 over 5 gives me a value at -4 there, and a value of 5 there, or a value of -4 here, and a value of 5 here. So now it says determine the missing side. And note that it is in quadrant 3. Oh, yeah, third quadrant there. So it is not that one. We're using that one. So it says it must be negative. So in this case, remember, if I know my longest side, then I'm going to subtract my values to find my shorter side. So I have 25 minus 16. 25 minus 16 is 9, and the root of 9 is 3. So given that value, I can now put that value in. This is 5, this is negative 4. Given where I am, this would have to be negative 3. And now that I have my triangle, I can do cosine and tangent. So cosine is adjacent over hypotenuse, and tangent is my opposite over my adjacent. So this one would simplify because they're both negative 2, 4 over 3. So now given my last one here, they want me to do it. It tells me that tan has to be negative and cos has to be positive. So the only quadrants where tan is negative and cos is positive is this quadrant right here. So this would have to be in quadrant 4 for cos to be positive, but tan to be negative. So given this value here, I know my tan, so that gives me my opposite side has to be 2, and my adjacent side would have to be 3, and the negative value here is going to go with the 2 because that would be the negative point. So then putting this into my Pythagoras' theorem to try to solve for my missing r side, I'm looking for the hypotenuse, so I'm going to add them. This works out to 9 plus 4, which is 13, and the root of 13 does not simplify. So the square root of 13 is right there, giving us a sign that is going to be negative because I'm in the fourth quadrant, and that would be negative 2 over root 13. Or again, if you rationalize your denominator, that would be negative 2 root 13 over 13. And you should rationalize your denominator because, again, that is more proper than writing it with a radical on the bottom. So going on to the next page, if it lets me switch pages here, which it doesn't seem to want to switch pages here. So what I'm going to have to do is, oh, now it's going to let me switch pages. So there you go. You have at the very top here, just remember trying to find an angle. So second cos, second sine, second tan will find you your angle, and that will help us with our values. Now just remember with this, because there are 2 quadrants in which sine is positive and 2 quadrants in which sine is negative, there will always be 2 answers for your angles unless they restrict the domain. So to find the angle here, I'd have second sine of 0.5, and second sine of 0.5 gives me an angle of 30 degrees. So that's only one possible answer here, an angle of 30 degrees. So if I wrote that out on my quadrants, 30 degrees is right there. The other quadrant where I have a positive sine angle is my second quadrant. So given that I might have a reference angle of 30 degrees there, my angle for that one there would be 180 minus 30, which gives me an angle of 150. So my possible answers for this would be both 30 and 150, because I'm allowed to have any answers between 0 and 360. So same, even if it's a negative answer, I'm going to have 2 answers there. So to find it, I'm going to go negative or second sine and just find my reference angle. And the reason I'm just going to find my reference angle is because if you put in the negative value here, it actually could give you one of 2 answers, and it could confuse you as to what your answer is, because they always want us stating our answers with the positive angle measurements. So while my calculator loads up there, I'm just going to find the reference angle for that. So the second sine of 0.8090 gives us a reference angle here of about 54 degrees. So now that my angle has loaded up, or calculator has loaded up, when I go to do this, second sine of negative, and I better make sure I'm in the right mode. Yep, degree mode. Negative second sine of negative 0.8090 gives us an answer of negative 54. So remember, a negative angle answer is just telling you that you are opening in a clockwise way as opposed to a counterclockwise way. So you have to just remember, if you do choose to do that, that tells you that that's negative 54 there, but we still want that answer there. So using sine law or cast rules for this, we can actually figure out what the values are. So for cast rule, because we know we have negative sine values, our answers would have to be in quadrant 3 and quadrant 4. So I have an answer there and an answer there. I know both of those reference angles are 54 degrees, so I just have to find my standard angles. So to do the 1, I'm going to go 180 plus 54, and that gives me one of my answers is 234. And then I'd have to go 360 minus 54, and that gives me an answer of 306. So my two answers for this are 234 and 306. If I do the same for cos again, I would just go second cos of the positive angle and get you your reference angle. So 8090. And I get a reference angle of 36 degrees. So going back to my notes, maybe my reference angle here is 38 degrees, 36 degrees, 36 degrees. So looking at which quadrants cos is negative in, it's negative in the second quadrant and the third quadrant. So I have to find that angle and that angle. So one of them is going to be 180 minus 36, which is 144. Oh, sorry. Yeah, 144. And the other one is going to be 180 plus 36, which gives us an angle of 216. And then for the last one here, same with tan. I just want to go find my reference angle and then use that to find my quadrant. So I have second tan here of 2.4586. And that gives me a reference angle of 68 degrees. Again, we're just going to round up. So that gives me a reference of 68. And then looking for my quadrants where tan is negative, it's negative in the second quadrant and the fourth quadrant. So I'm looking for that angle and that angle. So that would give me 180 minus 68. So I'd have one at 112. And then I'd have one at 360 minus 68. So my other one would be 292. So that's just another way to do it. Again, it's just a lot easier if you use it as a positive angle and then look for which quadrants your answer is negative in. So here on the last page here, we've got two more questions and we just want to solve. To be able to solve, I have to get sine, cosine, tangent by itself, and then I have to inverse it. So the first two examples here, they are all by themselves, but the second example, we're going to have to solve for tan and then inverse tan. So for this one here, I just have to sine inverse of 1. If I look that up on my calculator, second sine inverse of 1 gives me an answer of 90 degrees. And again, I could check my references for 90 here, but if I look at my reference of 90, my reference of 90 is right there, or my reference of 90 is right there. And one of these is a negative answer, and one of these is a positive answer. So I'm only going to have one answer there. It's going to be 90, because this would actually give us an answer of -1. And I can show you that right there. So if I put in sine of 270 on my calculator, I would get an answer of -1. So sine 270 is -1. So that one doesn't work. If I checked cos of 0, so I'd second cos 0 here. So cos inverse -1 of 0. That's going to give me an answer of 90 as well. So second cos of 0 is 90. But in this case, I actually have the two answers, because if I look at it, there's one of my angles. That's going to be 0. And there's my other angle that also has an x value of 0. So this one would have the two possible answers. So the angle is 90 and 270. And then for my last one here, I have to get tan by itself first. So this is just going to follow basic algebra rules for solving. So I should move my 1 first. I'm going to subtract it over. And that gets me to 3 tan angle is equal to 3. And then I'm going to divide both sides by 3 to get me that my tan angle is 1. And then I have to solve that. So my tan angle being 1 would be second tan of 1, and that's going to give us an angle of 45 degrees. Now, because we're looking for where it's positive, tan is positive in the first quadrant and the third quadrant. So I'd be looking for that angle and that angle. But if I look at my restriction says I can only use a value up to 180. So I can't use anything past 180. And that means my angle answer here is only just 45 degrees. I don't have to worry about the second angle. So for practice, I want you to try questions 6, 8, 11, and 18 in your book.